Greetings everyone. This video we will go over some of the Unit 5 study guide questions. This video will cover the ones that we will quiz over first, so I may skip around a bit. So in a future term, you may have two different videos and maybe a little bit of a scavenger hunt. But for my current people in January of 2025, this should fit with our first part of the quiz. All right, so first, when it says describe as exponential growth or decay, it is just asking you to make a choice, growth or decay. And you want to remember that how we know that is whether the base, and that's the one that has an exponent attached to us, if the base, in this case, it is less than 1, right? 2 out of 3, 2 over 3, 2/3 is less than 1, then we know that this is decay. Doesn't matter about the 5 in the front, the base. So over here, again, I see a base. Now this base is still a fraction, but this fraction, 6, is larger than 5. So this fraction, the base is greater than 1. Or if we had a whole number, that would also, of course, be greater than 1. So that base is greater than 1, so that represents growth. So it could still be a fraction and be growth if it's an improper fraction where the top number is larger than the bottom number. Or if I divided that, for instance, I would get 1.2, and that is greater than 1. So at some point during your first part of the quiz, you will need to tell if something is growth or decay, and your clue is going to be looking at that base. All right, the next two questions are graphing questions. And actually, I'm going to make my screen a little bit bigger just to try to give us as much space as possible here. You do not need to worry about the questions about end behavior. You will not be asked that. If you wanted to do that, you could, but you will not be asked that. And for this first one, we're going to keep it really simple, and we're not even going to use the -6. So you can mark out the -6 that's shown on here. We're just going to do a nice, really basic one. And so for any of these, whether it had additional parts or not, for exponential equations, I would recommend that you use -2 to +2 as your x values, and then be friendly with that calculator, right? So 3 to the -2 is 1/9 as fraction, but most of you are going to use your calculator and see something like 0.11. 3 to the -1, 0.33. 3 to the 0 power, remember we're doing this or this. Use that to the button, that caret. So anything to the 0 power is 1. This 3 is not being multiplied by anything, so it would stay a 1. 3 to the 1st power, 3. 3 to the 2nd power is 9. And then I'm going to try to place those things on my graph. So -2, 0.11, we are really close down here. Just making this dot big enough that you can see it. This is just a tiny bit higher. It still really wouldn't be halfway. 0, 1, 1, 3, and 2, 9. And that is about all that fits on this graph, right? And so then you're going to try to connect those with a nice swoop. Down here, this should stay, no matter how far in the negatives we went, it would actually never be 0. If I kept dividing something by 3, it would never be 0, but it would get really, really close. So asymptote, right? And then over here, it is coming up and it is growing very fast. And so that represents, just as a reminder, this is growth. It's not one of the questions at the right, but this is growth. I knew that before I made the graph because I saw the base was greater than 1. But when I look at it from left to right, I can also see that there is growth happening. It's going up as the x increases. Our domain, as it commonly is all real numbers. Or if you want to use some interval notation, you could say negative infinity to positive infinity. You don't need to give me both of those, but either one. And the range in this case, notice how it's only using positive numbers. So I might say that y is greater than 0, no or equal line, because it doesn't actually touch. Or I could say that it goes from 0 to infinity, because it keeps going up. There's no limit that way. The y-intercept, where does it cross the y-axis? That's an ordered pair. It's a point, and that is at 0, 1. If it's the y-intercept, it's always going to have a 0 for x, because by definition, that's where it would touch the y-axis. And the asymptote here is y is equal to 1. So it gets close, or 0, sorry. I wrote the right thing. So it gets close to 0, but it doesn't actually touch. It doesn't cross it either. It doesn't show up on the other side. If I had left that +6, the entire graph, if I had left the +6, the entire graph would have shifted up here. 1, 2, 3, 4, 5, 6. It would have been more like this and gone up. The whole thing just would have been pushed up 6 units. That's what the +6 at the outside would have done. And then instead of getting close to 0, it would get close to 6. And it would have crossed the y at 7. And my other points aren't necessarily accurate because I just tried to do a quick sketch. So, all right, let's look at the second one. I have left plus something on that one. All right, my friends, I paused the video and I did not restart the video. So try the second graphing problem on your own and see if your answers agree with mine. The +2, because it shifts the whole graph up. Yes, I've been talking to myself but not recording for a little while, but it's okay. But that shifts the whole graph up. So that gives us a clue about our range and our asymptote. That rather than y being 0 and my range being y is greater than 0, the y is 2 and the range is y is greater than 2. So adding or subtracting something will change the range and the asymptote. And then another clue here is I changed the 1/2 to 0.5. Most of you would want to change 1/2 to 0.5, and that would give you decimals for your ordered pairs that you're trying to graph. All right, thanks. Okay, friends, first off, I want to point out to you that you will be receiving a reference page. You received the top half of the reference page before. That reference page will look like this. This is the bottom portion, and you will see, for instance, the part that's going to be most useful for what we're looking at right now is this. So I think we've practiced it enough that you probably remember that B is the base, and he's the guy kind of in the basement with the log, and that X represents exponent, and then Y, we call that the argument. It's like the answer when we raise the base to that power. And so that you will have reference to when you're answering these questions, along with the log properties below. So I hope that those things will be should be very helpful reminders. All right, so I may refer back to this, and if I have not given you this, please ask me for it before it's the quiz, but I should remember. All right, so let me get back to the other page where our questions are. All right, so some of you may want to label first. Some of you may feel very comfortable just starting out putting it in log form. So if you want to label first, you might say that B is 8 and X for exponent is 2, and then that means that Y has to be 64, right? Because that's the only other choice. And so then when I write log, to change it to log form, my base is the 8. My Y is the 64. And my exponent is the one who gets to be over here alone. So hopefully, just remember it is not so easy as just looking like 8 to the second equals 64. No, it's not that easy. These two kind of switch places, so to speak. And that's because logs and exponents are inverses of each other. All right, so here we're just writing things in log form. So this is my base. This whole thing is my exponent. This is my Y. So now I'm going to say log base 2 of 32 is X minus 4. And you're not asked to solve this. It's just, if it just says convert or write in the other form, then you can stop after you've done that. If it said solve, well, then you got more stuff to do. So here, 10 is the base, 2x is the exponent, the x, and 54 is our y. So if we're changing it to log form, we have to have the word log, of course. So log base 10 of 54 is 2x. Now, if you're feeling like really confident, of course, you could just pause me, try problems, and then come back and check. We, at this point in January 2025, have not yet talked about natural logs, so I would not anticipate you would know how to do number 10, just to kind of tie things up, and as a little teaser of something that we'll learn later, we will say LN, and that stands for natural log, or log natural, I guess, because that's the way it's always written. When you use natural log, you don't have to write it, but the base is the E. And then this is, of course, still the exponent, and this is the y. And if the y has more than one part like that, I should put it inside some parentheses. And then the 6 would be over here. Again, won't be something like 10 or 14 on your quiz, so it's completely okay if you just skip those for now. They won't be on this first part. So, but we will talk about that, particularly that is something that you will see not on the Algebra 2 quiz, but you will see natural log questions on the Ivy Tech final. So we will do more practice with that. All right, down to number 11. Now we're just going in the opposite direction. Again, if you like, you can label B as 3 27 is 27x. No, 27 is y. And the x here is 3. And so here I would be saying that 3 to the third power is 27. In this case, there's 2 3s, so I guess if you got those two mixed up, you might be saved. If it's all numbers like that, you should be able to check it and make sure that it makes sense. But oftentimes, at least one part will be an X, so you can't really check it. You just have to trust that you're putting things in the right place, and don't be afraid to use that reference sheet if you need it. So here, this is my base, this is my exponent, this is my y. So x to the 1/2 power is 7. Base, exponent, y. So x is x in this case. So here, 4 to some power is 90. X would not be a whole number, right? Because 4 to some whole number power is not 90. And then remember, like my problem above, that doesn't say IN, it's LN. And we'll say ln of x or natural log of x. When we have natural log, we know that the base is e. So this is saying e to the 38th power, because this is still where exponent lives on the right, is equal to x. Again, you do not need to concern yourself with these two questions for now. So if you want to write them down, if you don't, it's okay. Later. Just a little preview. All right, so hopefully that part, especially knowing that you'll have that reference page, shouldn't stress you out. All right, so here it says evaluate each logarithm. So if we are evaluating, we should get a value. So a number answer. So a number answer. So we're going to evaluate, we're going to get a number answer. Some of them you could set up an equation using your knowledge of exponents, or at a glance you might just know. But remember that we can use change of base, and change of base means we're going to grab our calculator and we're going to do the log of a, or what we usually call y, and divide that by the log of b. And if you look at your reference page, you will see that's on the reference page, but I think on the reference page, those two things say y, but the same premise. You can use change of base as much as you want, but some of these you should just know, because for instance we know here that we are missing the exponent. So 9 to what power would be 81? Yes, the second. So I know that it's a 2. But if you do log of 81, remember to close the parentheses and divide that by log of 9, you also get 2. And again, remember keystroke wise, it's going to look like this. So that fraction is inputted as division. Be sure that you close that first parenthesis or things that are not going to go so well. So log base 81 of 3. So this is not the same as base 3 of 81. So if you set up an equation, you will likely come up with 1/4. And if you use change of base, 0.25. Because we're saying 81 to some power is 3. So the power would have to be something less than 1. All right, so Again, you can simply do log of 3 divided by log of 81. So these, if you try them, then see if you are getting the same answers, although I see that I got a little lazy and didn't fill out my paper. So this should be 1/2. And 6 to what power would be 1? Anything to the 0 power. So this whole thing we could just say is equal to 0. So 0. Again, you could still do log of 1 divided by log of 6. It's still going to give you 0. If you do not see a base, you could simply, that means it's a common log, you could simply type that directly in the calculator and get an answer. It will be the same answer as if you do log of 63 divided by log of 10. But if the base is already 10, this is all we need to do. And then that would be one that we would need to do some rounding. Okay, it does not say here how many decimal places. If we kept 4 places, which is I think what we did on our last assignment, 3, I believe. If we were to only keep 3, we would just say 1.799. I will be clear with how many places you should round. So here we're doing log of 95 divided by log of 7. So using change of base, and by the way, for 19, you must use a calculator. There's not a way that we've discussed of how to get that. I could estimate, I know it's between 1 and 2 and closer to 2, but I don't know how much closer. 19 through 22, you would just need a calculator, all right? 15 through 18, you can use a calculator, but there is a way to get those answers without a calculator. And again, 22, you don't need to worry about this at this point, but this would just be grab a calculator. You'll see there is a button that looks like that on the calculator, and you would hit that button, and then I try to make a cursive L so that you don't mistake it for an I. Let's see if I can come up with that real quick here so I can let you know what I got. Let's see. By the way, if you're using like your iPhone calculator, you actually have to put in the 42 first and then press the natural log button. So different calculators, but you won't be using your phone on the quiz. So this would be 3.7377 if I keep 4 places, because it's 6, 6, so this last 6 jumps to a 7. All right, okie dokie. All right, so with a classroom calculator that you've already been using, that part should be easy peasy. And I will go back and show you again that is, if you look at that reference page, and then you see here on the reference page is the reminder about change of base. So this is what you would be seeing, right? And then this is basically what you're putting in the calculator, how you find the answer. And since the calculator gives you parentheses, you need to close the parenthesis that's in the middle of the problem. All right, let's get back to where we were. I'm afraid to pause again because I'm afraid I'll forget to restart. So you should have some times here that you just fast forward because I'm like kind of hem-hawing around. All right, so our product rule. So you might remember for exponents, product rule was that we added the exponents. So when we have logs, if I have a combination of two things like this, two things multiplied together, it is the same thing as if I had each one and I add them together individually. Because remember, the answer here is an exponent, and the base would be the same. So that's why we add them when it's multiply. We also refer to this, what I just did, as expand. Okay, so what I just did to write the rule was I expanded. It got bigger, right? So we can expand, get bigger, or condense, get smaller, using these rules. And so here, quotient, when it's division, what will we do with exponents? Yeah, we would subtract. And it also makes sense if we add it with its multiply. Yeah, division goes with subtract. So if we want to split that up, they each get their own base. It's the same, but they each get their own. And then the subtraction sign is in between them. Like that. Now, if it is just M and N and there's just that one little part of it, I would not be required to use those parentheses. But if that value was, like X plus 1, I need to put it in parentheses. Okay, so the reason originally it's in parentheses is because it's saying the whole thing is the argument of the log. Not just the M, not just the N, the whole thing. So once we split it and they each get their own, we would not have to put them in parentheses. All right, and then power rule, remember, was about multiplying the exponents when we had exponent power rule. And what happens here is when we use power rule, the exponent jumps here in front of the log. So this becomes 3 times log base B of M. Oh, actually, but in this case, it's not a 3, it's just an N. Pardon me. Whatever that is. Again, these rules also. Okay, so let's take a look at the reference page. I want to show you that these rules also are on the reference page. And you'll see down here on the reference page, at the bottom of the page, it shows expanded form and then condensed. So if you are asked to condense, you are in expanded form and you're going here. If yours looks more like that, if there's only one log, you must be in condensed form and you're going back to expanded form. So it works both ways. And of course that slash, typically we would write more like this. All right, so just know that that's the same thing. Okay, awesome. Go back to our page. So we are being asked first, do you see how they have a log more than one time? So condense into a single log. That means we are only going to write the word log one time. And then I may be using more than one of these rules. So first, if you see a number in the front and you're condensing, that number becomes the exponent here. So this, and by the way, you don't need to write a base because these are common logs. That's why they don't have a base. So this part would become log of 2 to the third. Now, since it's a number, 2, we could actually figure out that that is the same as saying log of 8. And then to handle this plus, that means this is getting multiplied with it. But if I want to put that all together and the log is supposed to be on the whole thing, I either need to make like a big parenthesis with that, or I might even do this and distribute 8x minus 32. And it's all in parentheses. So that had a few little steps, but you're bringing the number in the front, putting it as an exponent to the closest one. Don't go all the way out there to the x minus 4. Since it's just a number, I can make that an 8, and then 8 times x minus 4, so 8x minus 32, but it's the log of all of that, so all of that ends up in parentheses. So here, we have a number in the front again. That is the exponent on this. So 324 to the 1/2 power. You could type that in the calculator. Keep in mind 1/2 power is the same thing as square root. So that actually is 18. And then I have log base 5. And then this is 18. Minus becomes divide. Divide it by 2. And then if I can do that math, I should do the math. So log base 5 of 9. And now that it's just a single number 9, it would be okay. It's okay if you leave the parentheses, but it would also be okay to just say log base 5 of 9 like that. Okay, so if you can simplify it down to just being a single number, then it's okay to not use the parentheses. All right, we're going to skip over. We're actually going to be skipping these two for now. So 26, now we're going the opposite direction. We're going to expand. And if I have like this with this exponent on exponents, I'm going to use my exponent rules first and make this 2 times 3 is x to the 6th, and 5 times 3 is y to the 15th. All right, so I'm trading that, just using my normal exponent rules. And then now if I'm just going to expand, if I have a constant, like a coefficient, and then each variable I have will each get their own log. So here I have x and I have y. So I'm going to need log base 3 twice. They are being multiplied because they're right next to each other. So I know I'm going to add in between. And then this first one is for the x. The second one is for the y. And then those exponents are going to jump to the front. So when we expand, our exponents jump to the front of the log. So this becomes 6 log base 3 of x plus 15 log base 3 of y. And maybe you are comfortable and confident doing that in the same step, which is okay, but I just wanted to kind of show you one piece at a time. So some of you will combine some of those steps. Also won't be looking at that one just yet. All right. Sorry that the study guide doesn't really go in the order that we covered things, nor is it really in the order of the quiz. However, I will also be giving you a practice test that will give you a little better idea of how things will be laid out. But I wanted you to have like a little more practice than just that. So on this page, on this video, I'm just going to talk about 34, 35, 36, which will actually be more like what you see on the very first part of part 1 of the Unit 5 assessment, because this is our exponential equations. We are taking this first part of the assessment, at least my plan today, is that we're going to take it before we talk about log equations so that there's not quite so much to remember at the same time. So remember to solve an exponential equation. The exponents, we're going to use the exponents, but the bases have to be the same. And so we're not looking at this right now, so don't look at it. So for number 34, you need to ask yourself first, are the bases the same? And no, they're not, because one base is a 1 and one is a 5. But could 1 be a power of 5? Well, 1 is very flexible. It can be a power of anything. So 1 is a power of 5. It's 5 to the 0 power. And then the bases are gone. We can drop the bases and we make our equation from these powers. So then 0 is equal to 2x minus 8. And we've got a nice little two-step equation. I'm going to add 8. Most of you probably don't need to see me write that, but that's okay. And then divide by 2. So in this case, x would be 4. And if you put 4 in for x, right, if you checked it, if you put 4 in here, 2 times 4 is 8. 8 minus 8 is 0. So that would be 5 to the 0. And is 5 to the 0 equal to 1? Yes, it is. So it works. All right, we're going to go from there down to number 35 and then number 36. So if you do not have the same base, you might end up getting a problem that already has the same base. But if you don't have the same base, you have to create the same base. And typically that means, except for the example with a 1, you're usually going down to a smaller number. So you'd want to ask yourself first, is 64 a power of 4? So 4 to the first is 4, 4 to the second, 16, 4 to the third, ding, 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 4 to the third is 64. So 64 is 4 to the third. But then that 64 is getting raised to the x plus 7 power. Be sure to use some parentheses there. And this side, because it already has 4 for a base, does not need to change. Now I see that those bases are the same, so I can drop the bases, and this exponents become my equation. And you can write this, or perhaps you might choose to distribute as you write it down. So 3x plus 21 is 5x minus 3. Need to work to get those variables to the same side. Perhaps you'll choose to put them on the right. I'm just going to choose to put them on the left. I'm going to subtract 21. I didn't quite write it there just because I'm running out of space. And then I'm going to divide by -2. And x is 12. So get the base the same. So the 64 got replaced by 4 to the third. Then we distribute it. Then we could drop the 4's and make an equation from the bases. So over here, 27 is not a power of 9. So in number 36, we would have to change both to something smaller. And in this case, the something smaller would be 3. So if you want to pause me, try the problem using bases of 3, and then come back to see if you're right. Or if you just want to work along with me, that's okay too. So 9 is 3 to the second. But remember, there was already some exponents up there, so we need those in parentheses so that that 2 gets distributed. And then here, 1 over 27. Well, 27 is 3 to the third, but 27 was in the bottom, so that would be negative 3 for the exponent. And again, already something up there, 2w. So that's not 2w minus 3, it's negative 3 times 2w. So we're going to get rid of those bases. I'm just writing down my exponents, including the parentheses. Now I'm going to distribute. And then over here, it's just negative 3 times 2w. There's not 2 terms, so negative 6w. Now, in this case, for a change, I'm going to move my variables to the right because there are no constants on the right. So it's going to be a little bit shorter if I move it over here. So now I have negative 16 is negative 8w. And when we divide by negative 8, positive 2. Good. All right, so that was a lot of information, but those are the type of problems that are going to be on the first portion of the quiz. And so I'm also giving you, the same day that you're working on this, I'm giving you the format that looks more like the quiz. So you can go ahead and, if you've finished with this, you can try those. And then, as usual, we will go over them right before you take the quiz. And then the other kinds of questions that are in the study guide will be on part 2 of the Unit 5 assessment. Okay? All right. Thanks so much.